So thank you all for joining. In the next around 50 minutes, we will do a little bit of a deep dive into advanced TypeScript, and maybe you will know after this session something which you have not known about before. Short introduction to myself. My name is Christian. I've been working as a software engineer for the last 15, 16 years now. I started back with Java, so with Java, Springs, and the Java EE ecosystem. And then like 8 years ago, I switched over to more of a full stack role since Angular 2 was released. So since then, I've been working with Angular, JavaScript, and TypeScript in the front end. But in the back end, I'm still working with Java, so no .NET from my side. I also am Microsoft MVP for web development and dev tools. I am a trainer on the side. I mainly teach stuff in JavaScript, TypeScript, and Kotlin. And I also do reviews on the side for front-end and back-end code. I also really enjoy doing talks like at conferences, meetups, or user groups. And I'm also a content creator on YouTube. So if you want to see more of the stuff I will be showing you today, you can also visit my YouTube channel, or you can go to my website, type.rocks. There you can find the GitHub, LinkedIn, and the link to my YouTube channel. And all the code you will find today will also be available on GitHub, so you can just copy it from there if you're interested. So if you have questions, we will make it like this. You can ask them all the time, and the QR code or the link is also on the next slides. You can always ask the questions when you go on this QR code or on this link, and we will then see the questions at the end, like on screen, and we can answer them right away together. All right, so let's get started. So the first thing I want to talk about is about mapped types. So let's say we have a type here, events, and we say we have an on property and a remove property. Now, what we want to do is we want to have a user actions object, and this should be of on events. Now, we want for each of the events, we want to have a corresponding function. Like, for example, for add, we want an on add, which is just a function which does stuff, and we have a remove function which does the same. Now, what we could do here is we could create this onEvents type manually. So we could say we have this onEvents here, and we have our onAdd, where we say this is a function which returns void, and we have onRemove, which also takes nothing and returns void. Now, what is the issue with this approach? The issue is that we currently have no connection between the events and the onEvents. So as soon as I change this base type, as soon as I change this to move, for example, we can see that the code still compiles. But I don't want this. I want that I get a compile time error because I don't have this onMove function in here. And this is exactly why we should use mapped types. By using mapped types, we can have a base type and derive from it. So the first thing we will do is we will extract all the possible properties from the events here. How do we do this? We create a new type. We call this event keys. And we say key of events. Now, what is now the type of this? We can see here, this has now add, remove, or move in there. This is like a union type. And when you see union types in TypeScript, this always means we can loop over them. We can use them to loop over each entry and do something with it. So how can we use this? Well, first let's remove these fixed types here. And we now can loop over our union. So we say key in event keys. And this is just a variable. You can call it whatever you like. This does not matter. But what we can say is the value here, of course, is, again, just a function. And now you maybe have already spotted it. onAdd here does no longer compile, because now it needs to be the same property name as here on events. So we have to rename this to add and to remove. And we also need to do this with move. And we can see here we now have auto-completion for move. So we have it now like this. But you're now maybe thinking, well, this is not really nice, right? Because now this is just the same name. But we want to have this on prefix and the capitalized first letter. But we can easily do this because we have this mapping functionality here, and we can now change this key. We can say as, and we can now use template literals like you would in normal JavaScript or TypeScript, where we can say we want a prefix of on, and then we use parentheses with the curly braces with the $sign, and we pass in our key. And now we can see here, we no longer have a compiling user actions object, because now we need to prefix everything with on. Because we have now taken the key we had, so add, remove, or move, mapped over it, and transformed the key into using on as a prefix. Now we are almost there. What we now need to do is we need to capitalize the first letter of our key. And we can easily do this using capitalize. This is a so-called intrinsic utility type. When we hover over this, we can see that we have no clue how this works in the background, because this is an intrinsic function which is handled inside of the TypeScript compiler. So this means basically what the TypeScript compiler does is it just capitalizes the string for us, but we cannot see this because this is not done in the type part of TypeScript, but in the TypeScript compiler part. Now we can see here, we now have add, remove, or move. And now we have exactly the same thing as we had before, but with the one change that we don't have to do, we don't have to update on events when we change events here. So when I change, for example, delete, then we can see here on remove does no longer compile. So we have to change this to on delete. And this makes it really easy. The last talk, which was on the stage for the ones who were in there, was also like about design systems. And I think this is also goes in the same direction, because we have one type we define once, and then we derive from it. We take everything from it we can, so we are not rebuilding everything, and maybe we have things which will no longer be in sync. Now we can see here we have these template literals, right? And they are quite powerful, but we can do much more with them. So let me switch over to template literals, and let me show you what we can do here. So let's say we have an RGB CSS here, and let's say this is just an alias for a string. Now we have a variable here, RGB valid, and we say this is of type RGB CSS, and we say RGB 123 like this. And this, of course, is valid, but what is if we want to create an invalid one, and we remove one of our numbers here? We can see here, of course, there is no compile time error, because, of course, this is just an alias for a string. But we can use template literals to narrow the type of our string. So we can say here, instead of this being a string, we use backticks for template literals, and then we say we want to prefix this with RGB and have our parentheses. And prior, we use this dollar sign curly braces key, but we can also use built-in types. So we can say, for example, we want to have a number in there, followed by another number, followed by a third number. And now we can see that line 5 does compile, line 6 does no longer compile, because the shape we've defined here for our type, for our string, is not matched when we create it like this. Now, TypeScript is really clever. When I, for example, go in there and I add an A at the end of 3, TypeScript understands that this is not a number. Now, I would have to change this to string to make it compile again. And with this, we can also do this where for other stuff. For example, when you have like DSLs or something like this, you can do really crazy stuff with this. For example, you could also build like an SQL type, which would check for correct select query patterns or so on. But you can do a huge amount of stuff by restricting your strings here. Now, but what we also can do is we can combine template literals with our mapped types to create really powerful types really easy without having to write all ourselves. So let's say we want to create a small CSS validator, which only allows valid margin paddings with the sizes. So the first thing we do is we have our gap type here, and we say this is either margin or padding. And now we have our gap position, and this is either left or right or top or bottom. Now, when you normally would create this manually, you would have to write this like 8 times, because for all possible combinations of the gap type with the gap position. But this is really error prone because you can easily have a typo in there, and then you don't have the correct types. So let TypeScript do this for you. We can say we have our gap CSS, and we use template literals here. And now we say the first type here is our gap type with a hyphen, and then we have our gap position. And what TypeScript now will do is it will create all possible permutations of our type and our position. So when we check this, we can see we now have all possible combinations of our margin and padding and left, right, top, bottom. So you don't have to create these multiple times. You only define it once, and let TypeScript do the stuff for you. Now, let's also do the same stuff for the size. So for example, we only want to allow rem and pixel for our margin and padding. So we have our size type, and we say we want to either allow rem or we want to allow pixel. And now we say we have our size CSS, and here we use backticks again. We say as a prefix it has to be a number, and as a suffix we want to use size type. And now TypeScript checks for us that when we use this type, it starts with a number and it ends with one of our size types. So, and now I promised you that we can combine these with map types. So how do we do this? We just say margin padding here, and we now create a map type from our gap CSS and size. So we say here key has to be in gap CSS and the type has to be size CSS. And now we have our const here, and we have our margin where we say this is margin padding. And when we now look for the auto-completion, I now type an M. We can see here we get the auto-completion for all possible keys, which have an M in there. So let's use margin left. And as a value, we have to provide a valid size. So for example, 1 rem. As soon as I remove one letter here, I will get a compile time error. Now, maybe what you can see is we get an error here on line 21. Because we are telling TypeScript, we want to have a value for each of the keys. So we tell him we have like these 8 different keys, and we want to have a value for all of them. Undefined is not valid. But we can fix this. We can add a question mark in here, because this way we tell TypeScript it's OK that we don't pass in a value for all of the properties. Now, what we can't do that easy is specify we need to have at least one. We would have to create like a utility type for this. But if you're interested in how to do this, just visit my YouTube channel. So this is like how we can combine map types with template literals, because this way we don't have to write this stuff all ourselves multiple times. Because this is now really easy. We can just, for example, add percentage in here, or we can remove something, and it will get just derived from all the other things which derive the things from the size type. Now, we have now talked a little bit about map types and template literals. Let me now show you about a type, which I think many of you are not using because it looks like really useless, but it is really useful if you know how to do it. So maybe let me show you how we can use the never type. So quick show of hands, how many of you have already used the never type? Yeah, some of you. So now, let me first show you what's all about the never type. Let's say we have a hello string here, right? And we have hello NDC in here. Now, this, of course, works because this here is a string. So we can assign this to the type string. Now, what happens if I change this to never? Now, when we check this here, we can see string is not assignable to type never. Because we know this pattern, this means we have a type and we try to assign something to it, and this does not work because the two types are not matching. Now, what happens normally when we say as any? This would work, right? But in this case, this does not solve this issue, because never can only be assigned to itself. And this is really important to understand. So never is only assignable to itself. So this means you can only assign something, an object or a variable, which is of type never to never. Now, you are maybe thinking, and I was thinking the same, well, how can this be useful? Well, because TypeScript uses never as a type where it thinks this should never be the case. You should never reach this branch in your code. And so let me show you an example which you can use in real life, and I think this would really help you to have more compile and runtime safe code. Let's say we have a function here, get country for locations. And we have a location here, and return a string. Now, what is this type locations here? We have a locations type, and we say just this is either Zurich or this is Oslo. Now we want to have for each of the locations the country. Now we could do this with if-else, but we can also do this with a switch case. So let me do a switch case here with the location, and we say here case Zurich, and we return Switzerland. Now we still get an issue when we do it like this, because TypeScript understands, okay, you have Zurich in there and Oslo, but you only have a branch covered for Zurich. Now what happens is, when you call it with Oslo, then you won't return a string, but instead you will return undefined. So because TypeScript understands that, we will just use case Oslo here, and we say return Norway. And now TypeScript is satisfied because all the branches which we could possibly pass to this function are handled here, are covered. But the issue always with TypeScript is that this is only compile time safety. When we run this code in production, then there is no types. This is just JavaScript. Now, because this is, the issue with this is that we could, for example, when we run this in an environment of JavaScript, for example, if you have this function in a library and somebody which uses only JavaScript uses this function, then this person could easily call this function with like Paris or anything else they want. And this is then basically like called with as any in TypeScript. So what we could do to solve this is we just go in there, we add a default case, and we say throw new error, and we say in here the location is not known. Now, I've been talking about that the never type shows us a place in our code which should never be reached. And this is exactly the case here. Because when we check what's the type, we can see the type here of location is never. Because TypeScript understands we have Zurich and Oslo, and this branch here, the default case, should never be reached. But what is the issue with our current implementation? We now have runtime safety, but let's say I go into code and say, but I want to also support Paris, so I add Paris in here. And let's remove this as any. And we can see we don't get a compile time error, because TypeScript says, yeah, well, you have not covered this in these cases here, but maybe you want to throw an error when Paris gets passed. And we can see here the location here also shows Paris. So TypeScript understands at this point the only thing which could be in there is the string Paris. So now we have sacrificed the compile time safety for the runtime safety. But by using the never type, we can have both. Because let's create a variable here. Let's call this exhaustive here. You can call this whatever you want. The type has to be never. Because what we now try to do is we try to assign the location to never. And as you can see, this throws an error because we tried to assign a string, which in this case Paris, to the never type. And because you can only assign the never type to never itself, we'll get a compile time error. But let's see what happens when we now add the case for Paris in here. When we add this and we say return France, we can see the error goes away, because now TypeScript again understands that all these three branches are covered, so the only possible way where we can reach this default case is basically never. And because we assign never to never, this works perfectly fine. Now, what we can do, of course, is you're maybe saying, well, linter will now say we have this unused variable. So we don't have to use this, because since recent versions of TypeScript, I think version 4.6, we can use the satisfies keyword. The satisfies keyword is really simple. What we can say here is location satisfies never. And what this does is the satisfies keyword checks what it's in front, what type has this object which is in front of it, and checks if it satisfies this constraint here. And this is basically doing the same as doing this assign to the never type. Because now, when I, for example, remove a case here for Zurich, we can see I get an error because now the satisfies keyword tells us location here is Zurich, but you want to assign it to never, and it does not satisfy this constraint. So by using this approach, we now have compile time safety and runtime safety. So when we add something here in locations, then we also need to add it in our case switch. Of course, we can also do this with if-else cases. So you don't have to use switch, of course. You can also do it like this. And if I, for example, remove Paris here, then this again will no longer compile. And I use this personally all the time when I have these different unions which I pass into a function, because I can make sure that I'm not forgetting to add the implementation of one of these cases when I change something. Because otherwise, you always have to think, do I want to have compile time safety or runtime safety? And with this, you don't have to decide one over the other. So we have talked a little bit here about the satisfies keyword. Let me now show you how we can use another really cool keyword and how it's used in TypeScript itself, the infer keyword. Now, infer is used to take a type and then just take a certain part of this type and create a new one from it. This is maybe a little bit theoretical. Let me show you how this works in real life. Let's say we have here a function, and this is a really simple one. We just have a plus b here. But now we want to have only the return type and store this in a new type. Maybe to have, for example, when you have a currying function, which just will take the return type from the last function and will just reuse it. So let's say we have an add return type here, and we can use a type from TypeScript itself, a utility type called return type. So we say return type here, and now we need to pass the type of our add function. So we can say type of add, and now when we check what's the result here, we can see we get back number. When I change this to string, we can see I get back string. Now, for the ones of you who are maybe new to TypeScript, it's important to understand that when we use type of in TypeScript, it's different than when we use it in JavaScript. Because if we use it in TypeScript, we get the real interface of the type we have, for example, in our case, of the function. It just not only returns like function or object or string or like these primitives which JavaScript has. Now, let's see how we can implement our own return type to see how infer looks like. So let's say we have our myReturn type here, and this will be a generic type, so it will take some types itself. Generic types are just like, I call them like the type functions of TypeScript, and we just pass in a type t here. And now we can do some checks on it. We can say, for example, if t extends a function which takes any amount of arguments and returns anything, in this case, we will just return any, otherwise we will return never. So what we are doing here is basically we are not doing an equals check, because in TypeScript you cannot say it completely equals, but we say if this is at least containing this function, then it's okay. So in case where this is with this t, the type we pass in, so this type of add, is in the shape of a function, we return any. So let's see if this is working. We can see here we get back any. But this is not really what we want, right? Because we just told TypeScript, yeah, if I pass in a function, return any. It does not extract any kind of type information from our function we pass in. And this is exactly where we can use infer. Infer we can put anywhere in the extends clause. So we can use infer anywhere in here. So what we do is we want to have the type at this position, like at the return type of our function. Now instead of any, we use infer, and then we say we use a variable where we want to store it. So we use r in this case. So TypeScript sees, okay, we have this t here. If this extends this function, then store the type which is at this position in this variable. And then we can just use it here and return it. And we can see now, we have now number here returned. If I change this to string, we can see we get back a string. And this is like a really simple way of using recursion, of using infer. Infer is extremely powerful, and at the end I will show you an example, which is also on my GitHub, where you can play around with it. But infer can be used also to further check if something is true or not. But I will not go into details because it will be a little bit too much for this talk. But you can do a huge amount of stuff with that. Now, we will use infer right away for the next topic. We will use it to do something very cool. We will work with recursion. So let's go into recursion here. Now, what you're normally doing when you are programming is you can like decide if you want to do a function called recursively. So for example, you can do a loop also recursively by calling the function itself. But in TypeScript types, you don't have the choice of using a for loop or of using recursion. You can only use recursion because the type system does not allow these kind of for loops easily like normal JavaScript or TypeScript. So TypeScript itself also uses recursion in its types. So where does it? Let's say we have a nested promise. And we have here a promise inside a promise inside a promise, and in there we have the string type. Now we want to know what kind of type we get when all these nested promises are resolved. TypeScript itself has a utility type for this. It's called awaited, and we can see it returns the string. Now let's think about how TypeScript itself does this recursively. Well, when we would do this in JavaScript, we would say we have like a function awaited, and we have our prom, and in here we then say, well, if prom equals promise. Of course, this does not work like this, but it's like pseudocode. If it is a promise, then we just call awaited again with the prom.inner type. Otherwise, we will just return the value itself, because as long as there is still a promise inside of this recursive call, we just want to call it again, because we are not interested in anything which is a promise. And this is exactly how it's done by TypeScript. Now we can do the same, for example, let's do the same for nested arrays. So we will build such a function to unnest our arrays. So let's say we have our nested array here, and we say this is an array inside an array inside an array, and in there is a string. Now we can see here we have this multi-dimensional array in there, and we want to unwrap this. Now let's do this. We have our unwrap function, which takes a t, and now we can do the same what we did before in our pseudocode. So what we will do is we will just say, as long as t is an array, then we will take this inner type, and then what we will do is, if this is the case, we will just call unwrap again with this inner type. Otherwise, we return t. Because as soon as we find something which is not an array, this is the type we are looking for. Now, how can we replace these question marks? We can use infer. We can let TypeScript figure out what is this inner type of this array and store the result in our inner variable. And then we just call it with this unwrap with our inner type. So exactly the same what we would do in normal TypeScript, JavaScript, we can also do recursively like this. Now let me show you here. We now call unwrap on it, wrap this here, and we can see we now get back the string. If I change this, for example, to Boolean, we get back a Boolean. If I change this to an object, we get back the object type. So this is like the simple way of using recursion, because this is just recursively calling into the type, and as soon as we find the thing we're interested in, we are just returning it. Now, the more complex thing is, if you not just want to return the type as soon as you find it, but you want to build a type yourself. But this is also much more powerful. So let's think how we could do this. Let's say we have a type RGB tuple here, and this is just a fixed length array. So when you hear the word tuple and you have never heard that, this is just you have an array which is only allowed to have an exact amount of elements in there. So this is how it works in TypeScript. You just say you have an array and you specify the types of the elements which are allowed in there. And we say here we have an RGB tuple, and we say 1, 2, 3, and we can see this is perfectly fine. As soon as I add one element, I get an error. As soon as I have not as much elements as I need, I also get an error. Now, just a quick side note, if you're using tuples or fixed length arrays in TypeScript, always be cautious, because what you still can do is you can still use push or pop on it. So to fix this, you can use read only here. And as you can see now, you no longer can use push and you no longer can use pop on it. Now, this is perfectly fine, right? But what if you want to have either 3 elements or 4 elements? Then what you would have to do is you would have to take this and you would have to wrap this in read only, and then you would have to say I want to have 3 or 4 elements like this, and then this would work, right? But what if you have like a fixed length of maybe 20 elements or 10 elements, or you want to allow not only numbers but also strings in there, and you need to do this all the time for different tuples? Then you have to create them all manually, right? So wouldn't it be nice if there was a way that we could say, well, we have a tuple here, and we want to say what's the length of this is, and we want also to say what kind of types we want to allow in there. Well, we can create such a type. So first, let's think about how we would do this in TypeScript or in JavaScript. Let's say we have a function called this tuple, and we have the length in there, which is a number, and we have our type in there, which in our case is any, because we are allowed to pass anything in there. And now we have our accumulator, and we say this is an empty array to start with, and this is an any array like this. Now, when we go recursively through our code, what we would do is we would check if the length equals the accumulated length. So if we have already put all the elements in there we need in our array. If so, we would just return our accumulated array. Otherwise, we would just call tuple again with the length we have, with the type, and we will now create a new array, spread the existing elements into it, and then we add another type. So of course we could also push an element to this accumulated array, but in TypeScript types this will not possible because this is just types. You cannot just push something onto an array type. Now let's see if we can take this code and write it in types. So we can do this like this. We say we have a tuple type here. We have a length property we pass to it, a type property, and we have an accumulator where we say this has to be of type array type here, where we only allow elements of this type in there which we specify. And we initialize this with an empty array so that we don't have to pass this all the time when we initially use it. And now what we do is we do exactly the same stuff as here in our function. We say if the length, and now we can't use equals, so we have to use extends. When the length extends the accumulated length, and maybe this looks strange when you first see it, because how can I access the property of a type here? But if you think about this, TypeScript needs to have a way to access the length of an array type, because otherwise it doesn't know how many elements are in this fixed length array, in this tuple. So we can access the length of this, and because how TypeScript works, it will always compare like the most specific types with each other. So for example, we pass in 3. At start this is 0, and 3 does not extend 0, so this will not work, so this will go into the else case. But as soon as we have reached the same length, we will just return our read-only accumulator here. Otherwise, we just call our function again with the length property, with the type we have here, and now we do exactly the same what we did in our function here. We just spread our existing types into the new one and add another type. And that's it. And when we now scroll up here, we can see that this is no longer not compiling, and we can see we have created this utility type where we can just pass the length we want to have and the allowed types we want to allow there. Now, of course, now we have the power of the TypeScript compiler, because now we can say we want to allow either 3 or 4 elements. And TypeScript will now create the possibilities for us for 3 or for 4 element for a 3 or 4 element array. We can also say we want to allow 3 elements which are either numbers or strings. And we can see here, this does also create this. And we can do this until a really huge number, until 999, and this will now create like a tuple with 999 elements, and of course I need to add the number here. And this will work fine. But as soon as we change this to 1,000, TypeScript will complain because TypeScript has like a hard stop of 999 recursion. Like some versions ago it was like 40, so they are steadily upping that number. So, but let's go back here to 3. And I think this is a really cool way of doing this, because now you don't have to create all this stuff manually for every possible combination you want to have in your tuples. And of course, this is not restricted to tuples. You can also create, like, for example, one example on my GitHub is like you want to create like a tree structure where you say how deep is the tree, like 10 layers deep, and then TypeScript will create for you this tree structure. So you don't have to do this manually. And this also makes your code, in my opinion, much better readable. And many times I get asked by people, well, but nobody can understand what this code does, right? And this is not even complex types. This is easy one. These are easy ones. But I think, me personally, it's always when I use like a library, then for example, I use sort on a list. Then I'm not worried how the sorting works. I also, if I look into the code, I would most possibly not understand how the sorting works in detail. If you treat this like as a library, which has clear typings or a clear interface how to use it, I think you should really use such types. And maybe, but of course, you need to have some people who maybe understand this. But if you treat this as a library, then I think you can really reliably use this. But even if you're not using stuff like what I've shown you until now, I think the next thing is something which all of you who are like who are working in in development in the front end and using TypeScript should really use, because this makes your code much easier to reason about and also much less error prone. So let me show you how branded types work. So I think all of us had this issue. Let's say we have an email here. This is a string. And we say this is me@type.rocks. And let's say you want to send an email. And the send email function looks something like this. You have an input here, which is a string. And in here you send an email, and let's create another function where you say log it, and we have this string we pass in here. And we do a console log here. It's not really doing that much, but let's use it like this. We have our log it, and we log this here. And we also send the email. Now, what is the issue with this function? The issue is that we only have a string as a primitive input. You can pass in anything you want. Of course, you can use it with the valid email, but you can also call it with totally not an email. Now, of course, you have two ways of handling this. The first one is you do an if check in here. You check if is valid email, then you do it, otherwise you maybe throw an error. But the issue is that I don't want this function that it needs to always check the input, is it a valid email, and then it just runs the code. Because I only want it to be able, it should just send the code, send the email from the string it receives. Now, the other way would be, you say you have a function, and you have is valid email here. You have a string which gets in there, you return a boolean, and you say return string includes, and of course, don't do this in production code, but for me, this is good enough. Now, if this is true, then we wrap this, so we say if is valid email, we have our email in there, we wrap our code, and this will do the stuff. But of course, you can see here, this does not really help us at all, because we can still use a string to send an email without wrapping it like this. Now, people do stuff like this. They go in there and say, OK, we create a type here, an email type, and we have a wrapper, and we say we have our email string in there. And now what we do is, everywhere we want to send this email, we pass around this wrapper object to make sure that we have no way of just passing a wrong string. And we can do this. We can use it like this. But you can see what the issue with this is, and why I personally don't really like this. Because here in logit, we just use a normal string. And now we need to unwrap our string everywhere we use this, we want to use it as a normal string. And I don't really like this personally. So wouldn't it be nice if we had a way of handling this like this, when we can say, well, everywhere we have an email type, this has to be of this type. It can't just be a string. Now, you can see here nothing really changed, because TypeScript tells us, yeah, well, email is an alias for a string, so email is a string, so nothing really changed, right? So, but let's do some baby steps here. So the first thing we will do is, we'll say this is valid email, is not returning a boolean, but instead it is a type guard. What is a type guard? We say string is email. Now, this maybe looks strange when you have never used it, but what this does is, when this function here returns true, then we narrow the type of this string. So we put in there a string type with all the properties of it, but we tell TypeScript, when this returns true, then the thing we pass in here is a string, but it is more of a specific kind of string, which also contains all the stuff which is on email. Now, currently, we can see here TypeScript thinks, well, why are you doing this? Because you pass in a string and you say, well, if this is true, then a string is a string, because email is just an alias to a string. And here is exactly where the branded types come into play. And I think this is really powerful. So we say to TypeScript, OK, the type email is a string, but it also contains an additional property. And we say we call this property brand. Now, you can call this whatever you want. We can call this NDC here. And this doesn't matter. But I like to call this brand, and as a value we say email. This also does not matter. It's only important that we have a property on there which does not exist on the string type. And now we can see some things have changed, because when we scroll down here, we can see that line 19 does no longer compile. Let's see what the issue with this is. string is not assignable to type brand email, because TypeScript tells us, well, you try to pass me a string here, but where is this brand property on there? This does not exist. You are not allowed to put in something which is only a string. I need this property. Now, this works here. This totally does not work anymore, but why does this work here? Why don't we have an error in here? Because we can see we have this type guard. And now I think the type guard makes a little bit more sense, because now we are telling TypeScript we are passing in a string, any kind of string it could be. But if this returns true, then you can be sure that the string here also contains these additional properties. Now, important is that this, of course, is not the case in JavaScript. When you would call this here with, when you would call the brand property on the email, this would return undefined, because this is only available for the TypeScript compiler. So we trick the TypeScript compiler in restricting our strings into not only the primitives they are, but into some shapes we want them to be. Similar like with the template literals, but in here we can make this much, much better for also, for example, we can check for regex in here. We are not restricted to the type system. We can use real JavaScript runtime checks. Now, of course, because of that, we have the send email here. Now, if I move this outside of this check, we can see now again error again, because the type here now is, the error here is string is not assignable to parameter of type email, because it's not an email. But if I now move this back in here, we can see this is now an email again. If I move this out of this if, we can see this is now a string again, because only inside of this guard we can be sure that this is this subtype string. Now, maybe you're thinking, well, okay, this is nice, but I don't want to wrap everything in such an if case, right? And this is where we can use assertions, type assertions. So we will copy this here, and we will say this is not is valid email, but asserts valid email. And we say here asserts string is email. And we can see here, line 17, we don't want to have a return anymore for this function, because what we are doing here instead is asserts is, as the name implies, asserting that this is always an email. And if this is not the case, we should throw an error. So what we do in here is we say, well, in the case where this is not including an @ sign, in this case, we will just throw new error. And we say here input is no email. And now, instead of using this if case, we replaced it with asserts, remove this bracket here, and now everything which is under this line 22 now makes sure, this asserts makes sure that everything under this line is now a valid email. Because TypeScript understands that if we reach line 23, then the string is an email. Otherwise, we would have thrown an exception, and it would not reach the next line. So you can see how this works when we move this up one line. We can see we get a compile time error. When we move this down one line, we no longer have an error. Now, I really like to use it for in cases where I'm really sure that a string is a certain kind of type, but I still want to check this, and everything after this line, I can treat it not as a normal string, but I can treat it as this subtype of string. Now, one thing you maybe have overlooked or I have not shown to you is that logit here, of course, works as before, because input here, which is an email, is just a subtype of string. And because logit takes a string, this works perfectly fine. I can use this email input here as a normal string. When I check what kind of properties I have access to, we can see I have access to all these different properties because it is a normal string. We just added one like synthetic property. Now, you're seeing here we have now access to this brand property, but of course we don't have, because this is only for the TypeScript compiler. So let's remove this. And what we can do is we can declare this brand property. We can say declare const brand, and we say this is a so-called unique symbol. Now, you maybe have already seen the stuff like this when you add like a declare in front of const, let, or var. What this will do is it will just tell the TypeScript compiler, listen, there is this property for example, window works like this. When you check what kind of type window is, when you click on it, then you will see you have somewhere in the type definitions, you will have declare variable window, which is then defined how it's the shape in your current environment. So we will now use this as a key here, and because unique symbols cannot be accessed, we can see here that now the brand is gone. So this way you can hide it from your production code. Now, of course, this is not the only thing you can do. Like you don't have to do it only with emails. I, for example, use it also for other stuff like IDs or for phone numbers, for all possible stuff where you don't just want to pass a string, but when you want to be sure that it has a certain pattern, it is a certain type. For example, I think all of you are working like have some kind of business domain where you have specific names which are always a string, or like property types which are always a string, but they have to have a certain shape. A UUID is a string, but it has to have a certain shape. A phone number has to have a certain shape. A date string has to have a certain shape. And if you're passing this stuff around only as strings, it's really hard to reason about what it is exactly, because you only have the variable name to figure out what kind of string you're working with. Now, what it also makes easier is, for example, let's say we have a type email and we have a type UUID, and you want to pass to the send email not only an email but also a UUID, and you have this UUID here. Then you also have no way of passing the parameters in the wrong order. When these two are just strings, maybe you pass UUID first and email as the later, but this is not possible when you're using branded types, because TypeScript will complain. When I now call here send email and I add a string here at first, then it will not work, because it tells, well, string is not an email, it's not an email, but also when I say email like this, we will see, hey, this email here is not a UUID. So you save yourself from passing in like strings or primitives in the wrong order. And also, of course, we can make this a little bit more generic. So we can say we have our brand string, for example, and we pass in our T. We say we have our string, and we have our brand like this, and the type is our T here. And now here, instead of doing this all ourselves, we just call brand string with our email, and this does exactly the same. Now, of course, you are not restricted to strings. You can also do this with numbers. For example, let's say we want to create a brand number. We say here number, and we want to say we want to have an integer type. So we can say brand number integer. And then you do like a check with your type guard if the number you pass in is an integer, and then you can pass your numbers around. And when you see, okay, this is a type integer, you can be sure that you don't have any floating points in there or any floating numbers, only like integers like you have in .NET, for example. And you can do this also, like, for example, only positive numbers, phone numbers, and so on. Like, this is basically endless, and it gives you a real easy way to also properly type your primitive types. Now, before we go to the questions, let me show you something what you also can do. And this is, of course, not something I would recommend you doing. This just shows you what you can do when you use all the stuff I've shown you today. And you can do stuff like this. You can say, for example, you have a validate function, which does, at compile time, check if this string you pass in is a valid arithmetic expression. So, for example, in here, we have, for example, when I remove this operator, we can see it throws a compile time error. So this checks for, like, are the parentheses in the correct position, are the operators there, and so on. Are there any letters in there which are not allowed? And you can see this. This is a little bit more. This is using a little bit more advanced stuff with the infer. And I think if you're really interested how this stuff works, this is also on my GitHub, and it really uses all the stuff we've seen here, like until branded types. Branded types are not used here, but all the other stuff is on here. So if you're interested in it, just visit my website or visit the GitHub repository. So let's go over to the Slido and let's see if there are any questions. Could you elaborate on why we defined a myReturn type and we already have the built-in return? This was just to show you an example of how you would implement this. I, of course, would not like just create all the built-in utility types with a my prefix and do them myself. This is just to show you how this works. What's the difference between type and interface? It's mostly the same, but this is like a huge topic, when to use interfaces and when to use types. But for you, I think this is really like bike shedding. Just use the thing you like, and if you use once an interface, another way you use types, this doesn't matter. Everybody understands what you're trying to do. You try to define a type, but there are nuances which are different between types and interfaces. For example, with interfaces you can work with extents, but with types you work with intersections. There are many different types, but I think there are some great videos up there on YouTube which you can watch. Not mine, I did not do this, but from other people. What are practical use cases for map types? For me, they are always when you have a base type, like what we have here. For example, let me show you. Let's check the time. Yeah. For example, for me, this already is a real-world use case. When you have a type and you derive something from it and you want to create a new type where you use this existing one, then in my opinion, this is a perfectly valid use case, because you don't want to have the headache of, oh, I changed events. I everywhere have to do a search and replace. Where are all these types? And then just replace them everywhere. You want to have it in one place and then let TypeScript do all the stuff. Because in my opinion, TypeScript should make our lives easier and not harder when we develop. What editor is this? Yeah, .NET I think uses more Visual Studio. This is IntelliJ, so from JetBrains, and I've used Eclipse for a long time, and then finally like everyone switched to IntelliJ, so I also could switch in my company. So really nice. I'm using IntelliJ exactly, and this, just a quick side note, I also have this on the side. This thing here you can use to see what kind of types you have here. This is a plugin called Wit, and you can find it also on I think for NeoVim. It's also available. I've created for NeoVim and for JetBrains products. For VS Code, this is called VS Code 2/queries. And this does exactly the same in VS Code. Can you get SOT to return branded types? I don't really think you can. For the ones who don't know what SOT is like a validation library where you can create a schema, and you can then check if your object you pass to the schema is valid, and you can also let SOT create the types from your schemas. So really powerful, but I don't think you can, because this is like only a TypeScript construct, but I'm not that into SOT to be able to tell you exactly. But I will look this up and I will answer the question later. TypeScript errors are often extremely verbose, often as a result of more complicated types. How can we keep the errors more ergonomic? There are also plugins in VS Code, especially to prettify these errors. And I'm not really sure if they're also available in IntelliJ, but you can look up for VS Code this like TS error prettify, I think it's called. So this will then really show you the final error much better than just this whole tree of errors. But they are still often really hard to understand, because the TypeScript type system allows so many different kind of types and complex types that, of course, the errors then also are complicated. Can TS emulate discriminated unions like F option sum of T none? I'm not into F# at all. Discriminated unions is like that you say you can have either sum of or none. I'm not really sure. I would have to look into this, what this looks like exactly, but I will answer the question later, because we don't have that much time, so we'll go through the other ones. Do you have a real-life example of how to use infer? Yeah, infer, you should, I think this is only when you have like infer, and all these other advanced use cases are mostly like for developers which create maybe a library, which will make sure that you can really use this in your code then more easily. They often use infer, but in a normal case where you do like a normal CRUD application, I would never use infer. So it's yeah. I don't have a real life example for a normal developer, but for like a library author which wants to have nice typings for the user. I think infer could be used to extract certain information that the developer knows better how to use which types. But as always, it depends. So what's your take on enums? I don't have any takes about enums. I know there are videos on YouTube where people say, well, don't use enums, use enums. It was an error. I never understood that. I just say, yeah, well, this is just construct. Use it if you want to, but if somebody doesn't want to use it, I think this is like if people don't want to work, then they say, yeah, well, we have to figure out if you want to use this or that. Me personally, I don't care at all. What extent would you define a type system in a real-world business app? Yeah, I think this is always like you have to keep a balance. Don't make it too complicated, because when you want to change something, then it's hard, and when it's hard, people don't want to use it, right? So you would have to find a balance between making it easy to extend and easy usable, but also don't make everything any, or don't like copy paste anything only because it's easier. I think it's important that also when you have an architecture of an app, always look that you don't like close yourself in and generate legacy code as you write the code, but also don't try to be too clever to like think about every possible issue which could happen in the future, and also and build this, because you most likely will not need it. Debugging app using this is scary. Yeah, maybe it is. If you're using certain stuff I've shown you with the calculator, of course. I think if you're using the more normal stuff like map types or template literals, then the error messages are quite easy to understand. But if you have any error issues, just send me a message on LinkedIn and we will look into it together. Maybe we can help another. Should I infer types or always make them specific? This is a great question. All of them are great questions, but this I like especially. So if you have a return type, should you let TypeScript figure out what to return, or should you define this explicitly? There I have a specific answer to this, because I think you should define them yourself, but I come from like a statically typed language, like from Java. I don't want to have everything inferred, because when I change something in my code and I infer everything, then maybe somewhere on the way I have a breaking change, or something does not work anymore, and I want to have the certainty about my interfaces of my functions. So on functions, I would always do this. Maybe when you create a variable, and it is like a constant variable, where you can see what you put in there, maybe then you don't have to, but I always would explicitly type this. Does the brand property need to match the name of the type? No, it doesn't. You can't just put in anything. You can just also put in like a description. It's only important that the key of it is not something which is in the string type. So don't put like toString in it, because this would TypeScript would say, yeah, well, it's in there. Is it possible to define regex directly on the type? No, there is. TypeScript can validate regex, but you can't do a regex. You can use this string, these template literals, to achieve similar stuff like regex, but this then gets unreadable really fast, and you always have to catch all the edge cases. So I will not do this. Also, the branded types have the really cool thing that you have runtime code which checks. It's not only like a type which gets stripped away during compile time. You always have your runtime code which will really check and which stays in production. All right, I think it's everything. So let's go back into the let's go back to the next slide. So before we go to the end, I think I speak for all the speakers which are here on the conference. When you leave, you have like these 3 different notes which you can take, and you can say if you like the talk or not. I personally would like if you would take the green one, but you can take any one, of course, because it's important, I think, for all of us to know which one you liked, which one you don't like, so that we can improve. So if you have any questions, just visit my website, type.rocks, or LinkedIn, and I wish you an awesome conference. Thank you for being here.